Objective statement 1.16. Calculate the relative formula mass, or MR, from the relative atomic mass, AR. So the relative atomic mass, or AR, is defined as the relative atomic mass of an element is the weighted average of the isotopes of the element relative to 1/12 of the mass of the carbon-12 isotope. And on this scale, carbon-12 has a mass of exactly 12 units. The relative isotopic mass is the mass of an atom of that element relative to 1/12 of the carbon-12 isotope. So what we're looking at here is the relative atomic mass is the sum or the weighted average of the isotopes. For example, we have chlorine-35 and chlorine-37 multiplied by their relative percentages to give the chlorine relative atomic mass of 35.5, whereas if you look at a relative isotopic mass, it's only for one isotope, so it's always going to be a whole number. So that number is going to be the mass number on the periodic table. So it's important that you know the difference between the relative atomic mass and the mass number. Okay, so the relative formula mass then is moving up one step. So we're already familiar with the relative atomic mass and we're familiar with relative isotopic mass. So now we're moving on to relative formula mass, or MR. So the relative formula mass can sometimes be seen in some of the worksheets as RFM, standing for relative formula mass in capital letters. It's the mass of a formula relative to the mass of 1/12 of the carbon-12 isotope. Now the way you get this is by adding the AR, or the relative atomic mass values, together for all the atoms in that formula. Okay, so looking at the first example, we have F2, which is diatomic fluorine. So this molecule, we're going to get the relative molecular mass of this, which is the MR. And the way we do this is by adding up the relative atomic mass of the two fluorine atoms. Now, in the periodic table, if we identify fluorine, we see that fluorine is 19.9. So 19.9. With the top number being the relative atomic mass, looking at our key, and the bottom number being the atomic number. So we use this information then to work out the relative formula mass of a fluorine molecule. So 19 plus 19 equals 38. So the MR, or RFM, of fluorine molecule is 38. So next, looking at Fe. So Fe is iron metal. So in a metal, we just look at the actual atomic, relative atomic mass. So Fe, or iron, so let's refer to our periodic table. So if we look at iron on the periodic table, we see that iron is 5626. So the MR of Fe is 56. Okay, so nextly, looking at H2SO4. So H2SO4 is sulfuric acid. And what H2SO4 means is that little 2 next to the H tells us that we have 2 hydrogen atoms, and the little 4 next to the oxygen tells us that we have 4 oxygens, but we only have 1 sulfur. So we need to find those values from the periodic table, and we need to add them up. Now, you're used to looking at the periodic table now, so we should just be able to add the values. Remember that you're looking for the relative atomic mass, which is always the top number. So in this molecule, we have hydrogen with a relative atomic mass of 1, we have oxygen with a relative atomic mass of 16, and we have sulfur with a relative atomic mass of 32. So we have 2 times the mass of hydrogen because it's H2. So that is 2 times 1. we have just the mass of sulfur by itself, 32, and we have 4 times the mass of oxygen, which is 16. Then we add all these numbers together to get the relative molecular mass, or the MR. So 2 times 1 is 2, plus 32, we're looking at 34. 4 times 16 is 64, giving us a total sum of 64, and 34 is 98. Okay, so looking at magnesium hydroxide, so MgOH twice. So what this formula actually means is it means we have 1 magnesium to 2 hydroxides. Hydroxide is OH, so we have 2 O's and we have 2 H's. So that 2 has to multiply by each thing inside in the bracket. So looking at our periodic table, let's identify our magnesium, our oxygen, and our hydrogen. So magnesium has a mass of 24, hydrogen has a mass of 1, and oxygen has a mass of 16. So magnesium has a mass of 24. Hydroxide ions, that's the O and the H stuck together. Oxygen has a mass of 16 and hydrogen has a mass of 1. So in total, they have a mass of 17, which we multiply by 2 because our little subscript tells us we have 2 hydroxide ions. So we have 24 plus 34 equals 58. So the next molecule is a bit more complicated. What we're looking at is hydrated copper sulfate, or copper sulfate penta-aqua. So the 5 is a penta, so it means it's coordinated with 5 water molecules. .5H2O or some XH2O is to do with water of hydration, and depending on the molecule, you can have a different amount of water surrounding that ionic compound, so different amounts of water crystallization. In your specification, the only one they require you to remember is the copper sulfate, so the hydrated copper sulfate or copper sulfate penta-aqua. So copper is 63.5, oxygen is 16, and sulfur is 32, and not forgetting hydrogen, which is 1. Okay, so copper is 63.5, sulfur is 32, and oxygen, but we have 4 of them, is oxygen 16, but we have 4 of them, so it's 16 times 4, which is 64. Now the next thing to do is to look at what this .5H2O is. So we're okay with the rest of it so far. So the .5H2O means that there are 5 water molecules surrounding this copper sulfate. So we have to have 5 water molecules. So the easiest thing to do is to calculate the mass of 1 water molecule. So we have 2 times 1 plus 16, so the total mass of 1 water molecule is 18. Now, according to our formula, we have 5 of them, so it's 5 times 18. So the total mass of water in that water of hydrated compound is 90. So it's 5 times 18, which is 90. So we need to add the mass of that water onto the mass of the rest of our ionic compound. So we just add all those numbers together now. So that is 63.5 plus 32 plus 64 plus 90, giving us a total of, giving you 249.5 as the relative formula mass of hydrated copper sulfates.